Welcome to the presentation of the paper MADE-WIC, Multiple Annotated Datasets for Exploring Weaknesses in Code. MADE-WIC is a dataset consisting of functions with their associated comments using a unique schema. The dataset can be used to further facilitate research in the detection of vulnerabilities or technical debt. My name is Moritz Mock and I will guide you through this presentation. The problem is that different annotations result in a performance difference of a given approach. Therefore, it is unclear if the approach is performing well or if it is performing well because of the dataset. Therefore, the approach needs to be evaluated with multiple datasets. However, there are no unified schemas among multiple datasets available. Furthermore, we believe that the leading comments, the comments right above a function, provide additional context for the function itself. However, those leading comments are currently not considered in literature. The approach looks the following. We use data fusion, in which we combine different approaches methods into a single dataset. Therefore, we leverage Divine and BigWool, two well-known datasets for vulnerabilities in source code. Additionally, we have created our own dataset and we have annotated it for weaknesses. The annotation for weaknesses was performed with the tool from Russo, which uses heuristics based on CWE. Furthermore, we have annotated Divine and BigWool also for weaknesses. And lastly, we have annotated all the functions for self-admitted technical debt and for security indicators through their comments. For the security indicators, we have manually inspected them, and we came up with a final set of 89 security indicators, which we have used for the labeling. The approach looks the following: that for the creation of the new dataset, we extract the functions with their leading comments using SOCML from open source projects, whereas for the existing datasets, we extract the features which we are interested, followed by the extraction of the leading comments from the original source. Then going over to the removal of the duplicates, we remove the duplicates for each project of each dataset. Additionally, if two datasets share the same source, also there the inspection was performed. Afterwards, we have annotated all the functions for the weaknesses. And we have annotated the functions through their comments for self-admitted technical debt and for the security indicators, resulting into the dataset MADE-WIC, which contains more than 850,000 functions and 2.7 million comments. We have 3 annotation methods for the vulnerabilities. We are spanning 12 projects, and we have 3 annotation methods of the functions throughout their comments. Additionally, we have evaluated the weakness annotation with the quality metrics from Croft. The application scenarios are the following 2. A singular multitask approach can leverage the annotation for vulnerabilities or the annotation of the functions through their comments for SAT and security indicators to predict if a function is vulnerable or contains a SAT or a security indicator, or all at the same time. Another scenario would be the summarization of source code into comments, which would facilitate an easy textual description for developer to spot a vulnerability in the function. To conclude my presentation, I would like to point out that we have created a dataset on a large scale with multiple annotations. We presented an approach which can be used to extend the dataset with further projects in the future. Additionally, we provide a set of functions which can be used to combine the columns of the dataset to further facilitate research. And here on the left, we see the dataset schema. With that, I would like to thank you for your attention.